Good day, everyone. I am Timothy M. Amado from Mapua University, and I will be presenting our research entitled Adaptive Neuro-Fuzzy Inference System for Indoor Air Quality IAQ Assessment of a Korean Unlimited Grill Restaurant in Metro Manila. So, in behalf of my co-authors, let me begin my presentation. So for the outline of my presentation, I will be discussing the introduction, followed by the methodology, results and discussion, conclusion, and references. The Philippine and the Korean government have a good relationship for over 60 years now. According to the Ministry of Foreign Affairs in Korea, in Metro Manila alone, the number of Korean residing is about 38,000 people. As a result, the establishment of Korean culture is very much welcome to us Filipinos. And as a result also, Korean-style barbecue restaurants has been growing fast in recent years. The environment of restaurants, both indoor and outdoor, needs to be conducive and comfortable so that the health of the occupants will be protected from exposure to the contaminants of air pollution. According to the United States Environmental Protection Agency, US EPA, indoor air quality is defined as the air quality of a spaces inside buildings and structures in accordance with the thermal comfort and health concern of the occupants. The determinants of IAQ were characterized by the US EPA Building Assessment Survey and Evaluation, also known as BASE study, and the occupants' different perceptions of the place were also considered. Assessing the quality of indoor air, CO2, dry bulb temperature, particulate matters, and RH are also considered. The recent developments in technology, especially in the field of computational intelligence, allows us to use its power in vast applications. In the field of air quality research, computational intelligence has been utilized such as in machine learning, where it is used in prediction and characterization of air quality, deep learning, where it is used in creating predictive models for air quality prediction. Fuzzy logic and soft computing strategies are also employed in determining the air quality index. So basically, the main goal of this paper is to acquire and analyze the indoor air quality of a Korean barbecue restaurant in Manila. Specifically, the researchers are trying to conduct an IAQ quantitative walkthrough that will investigate the level of carbon dry bulb temperature, relative humidity, particulate matter concentration PM10 and PM2.5, and carbon dioxide concentration CO2. After the quantitative walkthrough, the next stage is to conduct a baseline assessment of the air quality based on the data gathered and determine if these are within the standards. And last, to develop an adaptive Neuro-Fuzzy Inference System, also known as ANFIS, model to determine the air quality index of the Korean barbecue restaurant using the data gathered in the first phase of the study. So here's the methodology followed by the researchers in conducting the study. First is the quantitative walkthrough. A Korean barbecue-style restaurant where the main dishes are pork belly, which is called samgyeopsal, is chosen. The total floor area of the restaurant chosen to be the site of implementation of the study is 96 square meters with an indoor height of 3.2 meters. Appliances such as air conditioner, TV, electric fan, and others that may affect the study were also noted with checklists for subjective observation. So, based on the data from based on the standard of MVAC, for a total area of less than 3,000 square meters, we need one sampling point per 500 square meters. Since the restaurant is only 96 square meters, we only need one sampling point to conduct the quantitative walkthrough. Again, for the quantitative walkthrough, we have equipment that are used. First is we have 3 smart sensor AR807 thermohygrometers and 1 ASHRAE thermohygrometer to measure dry bulb temperature and relative humidity. To measure CO2 concentration of the restaurant, a vernier CO2 gas sensor device was used. For the general methods of sampling, the respirable and inhalable dust, the electric PM detectors was used. The researchers measured PM10 and PM2.5 for indoor and outdoor. The next phase of this study is the baseline assessment of the indoor air quality. The data gathered was evaluated as to whether the Korean grill restaurant is within the range of the accepted international standards. So we can see on table 2 the different standards based on ASHRAE. So the American Society for Heating, Refrigerating, and Air Conditioning Engineers. Here are the standard temperatures as well as some standards which is applicable in the Philippine setting. So we can see from the table for the dry bulb temperature, the range of temperatures that within the standards for relative humidity, ventilation rate, carbon dioxide concentration, and the particulate matter concentration as well. So the last stage of this study is the development of the adaptive Neuro-Fuzzy Inference system. So in this phase, an ANFIS was used to create a model that relates the instrument readings, the sensor readings that we have from the quantitative walkthrough and the baseline study, and relate it to the effective indoor air quality index. So the effective indoor air quality index is actually air quality index combined with thermal comfort index through weighted averaging. So the proposed ANFIS model to be used in the study is based on the Sogenotype Neuro-Fuzzy model. Neuro-Fuzzy models integrate the natural language description feature of fuzzy inference system and the learning capabilities of artificial neural network. So one main advantage of using ANFIS over the traditional fuzzy inference system is the rules that govern the inference system is automatically generated by virtue of artificial neural networks. So in the figure, we can see the different description for each EIAQI weightage. So excellent for 7. If your EIAQ is from 6 to 4, that's good. 2 to 3, that's bad. And if it's less than 1, that's worst. So for the results and discussion, so here are the quantitative walkthrough results. So we can see here the graph of temperature with respect to time during the lunchtime and the dinner time where the data is collected. So in the sampling, we can see here that generally the temperature readings inside the restaurant are above the standard temperature. So in all heights wherein the sensors and instruments are installed, we can see that from the standard temperature, it all exceeds. Relative humidity is also included in the study. The highest relative humidity reading of 71% was monitored at height of 0.7 meters, but all readings from the height of 1.7 meters and below are within the limits as there were air conditioners working, and the outdoor relative humidity reading monitored at the time ranges from 78 to 80%. So as we can see that it almost follows the standard provided by the ASHRAE and the Philippine setting standard for relative humidity. We can also see here as well the CO2 concentration. So we can say, based on the quantitative walkthrough result, that the CO2 concentration remain within the satisfactory range, again, because of the air conditioners and the ventilation that works properly. Based on the ASHRAE 62-2016 standard, the limit of the CO2 concentration is 5,000 ppm, and as we can see that this standard is met in during the lunchtime and during the dinner time in the Korean barbecue restaurant. we can also see here the data about the particulate matter concentration. So as an observation with the results, there are more occupants during the dinner time than during the lunch time, and the more occupants are there, the more grills are being used, which led to too much higher particulate matter concentration during dinner time. So the ventilation is also measured. So the actual ventilation rate changes from 10,599 to about 16,000 liters per minute, while during lunchtime, it ranges from 9,200 to 14,900. The actual ventilation is lower than the standard ventilation. So it is within the range of the standard. So the next result is the discussion and result of the adaptive Neuro-Fuzzy Inference system. So using the information gathered from the quantitative walkthrough as well as the data that we use for the acceptable standards, the adaptive Neuro-Fuzzy Inference system was trained. The structure plot of the ANFIS model is shown in the figure. The model has 5 inputs, which corresponds to the different instrument readings: temperature, humidity, carbon dioxide concentration, PM2.5, and PM10 concentration, having membership functions, 2 membership functions, and 32 rules. So the membership functions and the rules are automatically generated because the inference system is adaptive Neuro-Fuzzy. So that's the advantage of using artificial neural networks in conjunction with fuzzy inference system, because it yields automatic configuration. However, the way that the membership function is done is you need to specify what membership function you should use. So table 3 shows the root mean square error of each type of membership function when the ANFIS was trained. So in the research, we use the different membership functions like triangular, trapezoid, bell, Gaussian, pie shape, different sigmoidal, and product sigmoidal. And among these, we see that the different sigmoidal membership function has the lowest RMSE. So take note that the lower RMSE is, the better. So the system was able to attain an RMSE of 0.0035 in 15 epochs. So after training the ANFIS model, it is validated using sampled values from the training data. So the figure here shows the result for the 6 samples taken from the training data itself, and we are able to attain 0.0083 average error. So we can see from the graph that the predicted EAIQ in a given instance is almost the same as the predicted value. Lastly, a testing for the out-of-sample error was also done. These samples were taken from the data gathered from the quantitative walkthrough. So the model was able to achieve an average of 0.5623 error. So using out-of-sample data, the data that was not part of the training set but part of the quantitative walkthrough, we are able to see or to test the accuracy of the model, and it's good. It performs well, and it also evident that the IAQ of the Korean grill restaurant in Manila resides majority from good to bad, as expected from the quantitative walkthrough results, because most of the time the levels that we got from the quantitative walkthrough is below the standard. So for the conclusion, the study focused on the indoor air quality baseline study of selected unlimited Korean grill restaurant in Manila. Sa the IAQ-related parameters, dry bulb temperature, relative humidity, carbon dioxide concentration, particulate matter concentration, PM2.5 and PM10, and evaluated with respect to the ASHRAE 62.1-2016 standard in conjunction with the Philippine standard as well. Results showed that these parameters exceeded the standard during lunch and dinner times. The next phase of the study is wherein an adaptive Neuro-Fuzzy model was developed in the study to create a model that relates the IAQ parameters considered to the effective indoor air quality index that integrates air quality index and the thermal comfort index. The ANFIS model developed used different sigmoidal membership function with an RMSE of 0.0035. Training and testing validation and evaluation resulted to an average error of 0.0083 and 0.523 respectively. So here are the references that we use in this presentation. So thank you for listening. Once again, I'm Timothy M. Amado from Mapua University, presenting our work, Adaptive Neuro-Fuzzy Inference System for Indoor Air Quality Assessment of a Korean Unlimited Grill Restaurant in Manila.